This project is used for patient health record maintenance with data security. Here we take the image as a ECG image, input image as a ECG image. You can take any image because this project is molded based on data security with image metrics. You can do according to your concern, but the concept of the work is same. If you input one image, that will be watermarked and encrypted, which will be reversed by using the same technique. So this is the principle. Here we are using AES encryption technique and DWT watermarking principles. Here I applied. So first we need to execute this main.m file. Just right click, give run. It will ask you to enter the input data, patient data. Here I entered. This record is confidential because it belongs to VIP. So if you want to hide any personal or VIP or any important person data, so it will be confidential to maintain. That's why this project is applied to patient health data. For example, if you admit any VIP to one particular hospital, you need to maintain secrecy over the health records. Then you can apply the same procedure. Here I am inputting the ECG signal as an input. If you want to give the default inputs, you can give one. Otherwise, it will ask you to enter patient heartbeat, amplitude rate. These things you can enter manually and you can execute. Okay. Here I enter default settings. Just give one. Automatically, details will be here. Here you need to enter the bit plane to encrypt your data. Here I applied 1 to 8. You can give anything. I give 5. So character string is 92 and this much pixels is required to encrypt the data. So your data is encrypted into the particular image. The message will be producing and the data is hidden over here. This is the first one. That means ECG signal you are inputting to the code. Next one, that particular ECG signal is converted into the WST format. That means WST coefficient format, which will be giving more security to the input image. Even the data is extracted, the image cannot be extracted from the attackers. That's why we need to convert the original image into WST coefficient format. That will be applied to this DWT image. Actually, the original image will be converted to WST coefficient image. That will be embedded to this DWT image along with the input you are entered. So this is the fourth figure. The original grayscale cover image, the cover image with your hidden watermarked data, image with your string hidden in the upper left column. So this is the original secured image. I close all this. Now we need to decrypt the data. Another end we need to decrypt the data, correct? So I execute this decrypt.n. It asks me to enter the bit plane. There I enter 5 now. The same I need to enter over here. So you can recover the image back. The record is confidential because it belongs to VIP. It will be written back. The same WST coefficients is also written back. Here there is a PSNR value. This is the image metrics. We can get mean square error, normalized cross correlation, average difference, structural content, maximum difference and normalized absolute error. So these all will be returned as it is. Then this is the received signal. That means your original record. So here you can use this one to compress that means graph you can see as it is like the input. So this is the input ECG signal you can get now. So same thing over here. So in this project you can get watermarking, encryption and decryption for health record. Here I am using. You can use any kind of images, digital images to encrypt and decrypt the same format with the watermarking. Okay.